Hi. You've seen the demos, multiple AI agents working together to complete a task. It looks great, but when engineers try to build this for the real world, it almost always breaks. Why? Because they make one fundamental architectural mistake right at the beginning. Today, in this video, we're going to talk about that mistake and then we're going to architect the correct production ready solution piece by piece. Let's dive into it. So let's start with what everyone thinks is an agentic AI system. You can see that there's a user, the user sends requests to the agent reasons, and if needed to solve the user's request, sends a query to the tool, and the tool returns the information. And agent can use multiple tools. The tools return information to the agent. It packages it, structures it, consolidates it with the other information, and returns it back to the user as the answer. Now, this system works perfectly in a demo setting, but it's a disaster in production, and let me share why. Let's say we have a number of agents. Let's say we have 50 agents across an organization, and let's say we have 20 different tools that are being accessed by one or more agents. Without a proper architecture, that's potentially 1,000 custom integrations, right? 50 into 20, 1,000 custom integrations to build and maintain. Now, each one of these connections, let's say number of tools, each of these connections breaks when the APIs change or when the format change or when there's any change in any of the tools. You need to go back to the agents using those corresponding tools and change the code. This is a nightmare in production, right? The solution is this layer called Model Context Protocol, or MCP. How does it work? Let's look at this. Now, every single agent can have connections to the MCP server. Let's say 50 connections for 50 agents. And let's say you have 20 tools as before, each connected to the MCP server. By introducing the MCP server or a number of MCP servers, we reduce the number of tools from 1,000 to 70. Every agent talks to MCP in the same standardized manner, and MCP handles all the tool-specific logic. For every single tool, we have one or more MCP servers, and we have MCP client within the agent application runtime. In our old model, every agent had direct access to every tool. This is incredibly dangerous because what if the agent should not access a particular tool and it's able to access that tool using the direct custom code, right? So there's a security problem with the standard user application tool access without MCP. With the MCP, now the agents never talk to the tools directly. They go through MCP client and the MCP server. Every request goes through MCP first. The MCP checks whether the agent requesting the tool is authentic. It checks whether the agent has permissions to use the tool or not. And once it authorizes that this agent is authentic and it has permissions, only then it sends the request to the respective tool, gets the information back from the tool and transfers it back to the agent application via MCP client. Let's see how this works in detail. So the user sends the query to the application. The agent logic within the application would use one or more LLM clients to fetch the answer to the user query. The LLM reasons, and if needed, if it needs a number of tools, what it does is there's a common thing called a server registry available both to LLM client and MCP client. This server registry has information of all the MCP servers and their corresponding tools as well as their capabilities. So LLM client would look into all the tools or the MCP servers available, would check their capabilities, and let's say it figures out that it needs a calculator, for example. What it does, it will reach out to MCP client with a request to access calculator tool. This MCP client formats the request, consolidates this request along with an authentication code, and sends it in a particular global format to this to the MCP server corresponding to the tool needed, which would be MCP server 2 in our case. So every single tool has a corresponding MCP server. One particular tool can have more than one MCP servers depending on the load. So let's say now the information reaches MCP server number 2. What this server does is it will check whether the agent is authentic and has the permission to access this tool, grabs the API key from its own records, and then requests the information in the format needed by the API, in our case calculator API. The calculator API returns the information, MCP reformats and structures the information, returns it back to the agentic application and the agent logic with the help of MCP client. This whole thing ensures that not every agent can access not every MCP server. It takes care of all the formatting needed for a particular API, and it provides a generalized way to access information from external tools so that the application doesn't break in production. It's modular, and you have a whole registry of servers accessible by different agents depending on the accessibility.
So let's recap. We started with a simple demo that would create 1,000 integrations in the real world. And by introducing MCP, Model Context Protocol, we have solved 3 critical problems. 1. We eliminated the M into N complexity explosion from 1,000 integrations down to merely 70. Second, we added a security layer that controls access and permissions. Third, we created an abstraction layer that handles all the API complexity so agents can focus on reasoning and not on integration details. This is the fundamental difference between a demo and a production system. It's not just about having smart AI capabilities, it's about the right architecture that makes the system reliable, secure, and scalable. This video is just the beginning. In the next one, we'll talk more about MCP, especially with the multi-agent systems in production. Stay tuned.